Hello boys and girls, it's Mr. Giomini. Just a little bit of refresher, a little bit of review for you for vertical and adjacent angles. What I've initially drawn here is just two intersecting lines. I'm now going to plot some points on it. Where these two lines intersect, I'm going to call that point B. Then I call this ray. This would be ray BA. I'll plot point C over here. We'll plot D here, and we'll plot E over here. Now I could say I have several angles here. I have angle ABC. I can reverse that and say angle CBA. I have angle ABE. I could reverse angle EBA, or just call it angle B. So I have several angles here, EBD. But now I want to talk about vertical angles. Now sometimes we call vertical angles also opposite angles. They are opposite each other when we have the intersecting lines, or when we have two parallel lines with a transversal going across. Now I look at the word vertical, I see the word vert. When you think that, think of the word or the term vertex. So vertical angles, or opposite angles as we also call them, share a common vertex. Well, the only vertex in this is located at point B. So I'm going to take my highlighter here, and I'm going to highlight one of the angles. I'm going to highlight angle ABC. I'm going to write it over here. So the correct way to write it, remember, put the angle sign, angle ABC is opposite, or is the vertical angle of, now we have to be careful with this, is opposite angle. Remember what I said, they share the same vertex. That's the only thing they share. They do not share a same side. So if I take a look, and I'm not going to highlight, but I'm going to kind of just over my arrow hill. So I also have angle CBA. Now, they do share the same vertex, but notice they also share same side, side BC. I don't want, in vertical angles, they don't share the same side. They only share the same vertex, and they're opposite each other. These two are what we call next to each other, or adjacent. So this is the angle on the top. The opposite of the top is the bottom. So I'm going to grab my highlighter here. I'm going to go over another color. So the vertical angle or opposite angle of ABC, the angle that it shares a vertex with but no side, would be angle EBD. So I could say angle ABC is opposite angle EBD. Notice what I have here. I have the center point, or where the angle is formed, the vertex, is the same for both, but notice none of the letters are the same after that. So when I'm looking for vertical angles, that center point where the angle is located, the vertex, will be the same in each angle, but then the other two letters that bookend that angle will be opposite. Okay, now that we have an idea of opposite angles, I'm going to clean some of this stuff up here. I'll put my points back on. I want to now talk about adjacent angles. Now adjacent is just a fancy word for next to. So if you think about it, when you're sitting in your classroom, the person adjacent to you is next to you. So put my points there. Now I'll leave this up here. Now we have adjacent. I always think of adjacent as next. Next to. So adjacent angles. Okay. Now, and when we notice in vertical angles, they share the same vertex. What we notice about adjacent is they're going to share the same vertex, and they're also going to share a common side. So they have to have two things to be an adjacent angles. To be adjacent angles, they have to share the same vertex and the same side. So I'm going to try to choose a different angle this time. I'm going to highlight it again. I'm going to choose angle ABC. Or E, sorry, angle ABE. Now we notice about angle ABE, okay, its opposite angle would be, or its vertical angle would be CBD, from the left to the right. Now with my adjacent angle, I need to find an angle that shares both the same side and the same vertex. Well, I actually have two choices here. I can do either, I could do angle ABC. Notice they share side AB together. That makes them adjacent, and they also share the same vertex. I could also do angle EBD. Notice they share the same side, EB, and they also share the same vertex. So adjacent angles could be angle ABE is adjacent to or next to angle, and let's see here, we said EBD. Notice what we have in common here. We have the same vertex, and we also have 2 points that are the same. We have BE and EB. So you will see in adjacent angles that you will have 2 common points, which means the common side that they share. Okay. Another thing we're talking about is complementary angles. We had that video, complementary. Remember, there's one P in that. If you turn the P around, it looks like a 9. It has that 1 0, which we can make equal to a 90. So complementary angles must always equal 90 degrees. Okay. If I take a look here, I can see right now that angle EBF is a right angle. Then that also means angle, I'm sorry, did I say D? I said DBF is a right angle. I also know that DBA is a right angle. Now I'm going to pull my protractor out because we need just a little extra practice with measuring angles. So I'll get my protractor out. I'm going to measure one of these angles real quick. I'm going to move my protractor over to where the vertex is. Now, right now it doesn't look too good. I want to make it so it's at 0. Okay. Now, nice little trick my friend Mrs. Brodke taught me is when I'm at 0, start counting by tens. So I go 10, 20. Now it's not quite 30. Looks like here it's about 28 degrees. So this angle measures 28 degrees. It's not yet to 30, so I can't make it equal to 30. Now, I'm not going to use my protractor to find, so the measure of angle EBF, so the measure of angle EBF equals 28 degrees. Now, I want to find the measure of angle DBE. It's complement. Now, I know that from here to here, this whole sector here is 90 degrees. Well, I already have 28 of it. So to find the measure of angle D, let me go back here. So to find the measure of angle DBE, I take what I already know. I take that this is 28 degrees. Altogether it's 90. I want to find out what part I don't have, so I'll take the 90 that I'm supposed to have total, take away from that the 28. That becomes an 8. This becomes a 10. 10 minus 8 is 2. 8 minus 2 is 6. I say that this is measured to 62 degrees. So that means this section here is 28. I'll do my little arc here. And this section here is 62 degrees. Together, these two angles are complements of each other, and complementary angles always equal 90 degrees together. Hope this helps. Take care.